Hello all and welcome back to video lectures on decision analysis, and now we are in chapter 6 called Catherine Kato's scientific report. And as in the last chapter was introduction or help how to do your assignment yourself, so this chapter is an example for your second assignment, ministry report. And this ministry report assignment and how to do it is given in chapter 8. But let us start this section 1. As previously, we have problem description, decision matrices, and decision rules. So let us describe the problem. So we have the Caligula Institute, that is a libertarian think tank, and Catherine Kato works for the Caligula Institute. And she is assigned to write the scientific report of what kind of policy should Finland adopt in the pending koala Ebola pandemic. And then again, recall the koala Ebola. It has only been encountered in Australia, but unfortunately Australia is a popular tourist attraction and the koala Ebola has penetrated the entire land. Australia has not enforced any kind of quarantine yet, so it may be only a matter of time before we may have a global pandemic at our hand. So this is the pending koala Ebola pandemic backstory we have had in this lecture notes previously, and it's also enforced here. And then I should be honest at this point, so I'm honest in being dishonest. So in this chapter, we have used decision matrix technique in a less than honest way. We have basically decided what we want and we cook the numbers to show the result we wanted. And how this is done is revealed in the Appendix B secret supplementary protocol. So wait for that. So what are the actions or alternatives that Catherine decides to consider? So these are the different economic policies Finland should implement. So A1 is extreme laissez-faire policy, A2 is laissez-faire policy, A3 is the current policy, A4 is regulated policy, and A5 is extremely regulated policy. So in your assignment, it could be a nice touch if you would open a little bit what does, for example, extreme laissez-faire means and so on. So these are just the titles. So of course, what is the contents of the policy is a bit unclear from the title, but let's now stick on these titles so you can guess what it means. And then what is the decision matrix? So the decision matrix, there will be only one of them. So this Catherine Kato's exercise as also your assignment on the ministry report will be a bit smaller in scope than the your fall or the sophomores, but this is maybe a bit more ingenuity or originality is involved. So there is only one decision matrix, and this will be the GDP development, and changes in percent is the unit. And there are two essential uncertainty involved with the GDP. So one is the koala pandemic on or not, and is Finland's export thriving or not. So only two yes or no questions, which gives us four scenarios. S1, koala Ebola is contained and export is thriving. S2, koala Ebola is contained but export is not thriving. S3, koala Ebola is pandemic but export is thriving. And finally S4, koala Ebola is pandemic and export is not thriving. And then we need probabilities for these scenarios. And again, I've used P0 as an unknown sensitivity parameter for, and now it's for the koala Ebola is contained. So this is the other way around as before. Sorry about that. And using Harrison-Stetson method, so meaning I just took the numbers out of my hat, the scenario probabilities will be P0 will be 75% of the P1 is 75% times unknown parameter P0, P2 is 25%, and so P3 Q0 the same, but the other way around, 25% Q0 and 75% Q0. Q0 is again as 1 minus P0, and the sensitivity parameter P0 for the koala Ebola containment is unknown. So we treat P0 as a sensitivity parameter. And now I have not used the maximal entropy principle, so these are not 50-50, but 75-25, 25-75. Why these numbers? So they can be criticized, but I just, at this point, I assume that, for example, if the koala Ebola is contained, so P1 or P2, so that's P0. So in the 73/4 times the export is thriving, only 1/4 the export is not thriving, and the other way around when we have pandemic at our hands. So why not? But of course you can criticize these numbers. And then comes the GDP changes in percentages, and these are according to the best economists. Here they are. So for the excess, laissez-faire, current, regulated, extreme regulated, and these are the S1, S2, S3, and S4. I've given the probabilities here, not the labels, and these are the percentages change in GDP. And these numbers are based on the following observations. So extreme laissez-faire policy is good if koala Ebola is contained and export is thriving. Koala Ebola risk for this policy is considerable. Laissez-faire policy has less koala Ebola risk than extreme laissez-faire policy, but the risk is still considerable. Current policy has little koala Ebola risk, but does not exploit thriving. Sorry, there is a typo. Thriving exports very well. Regulated policy can handle koala Ebola risk very well, but cannot exploit the thriving exports very well. An extreme regulated policy can handle the koala Ebola risk very well, but is the worst in exploiting thriving export. So these are the observations that we assume to be true, and once you analyze these observations, you come up, or the best economists in the land come up with this matrix. So this matrix can be again criticized. So in a macro level decision making, such as Catherine's problem, the expected value rule is the most sensible choice. Okay. However, the expected value rule is sensitive to uncertainty probabilities, so the P1, P2, P3, P4 we have, or the P0 we have. So we want to temper this expected value rule sensitivity with the Hurwitz rule. So Hurwitz rule is non-stochastic, it's not sensitive to the probabilities at all, it doesn't depend on the probabilities. So if we add this rule to our expected value rule, so it's expected to be more robust in the sense of the probabilities. So what we do, we combine, we have a new rule V depending on koala Ebola is contained, probability P0. So P0, remember now it's the other way around. It's not the pandemic probability, but the non-pandemic probability. And then we have W, which is the degree of optimism in the Hurwitz rule, and we add these two with the equal weights 0.5, 0.5. So our decision rule V P0W is 1/2 times the expected value rule depending on P0 plus 1/2 times the Hurwitz rule depending on W. And of course, once we do this, we assume that the expected rule and the Hurwitz rule are assumed to be affine scaled to the interval 0, 1. So we never add two rules that are not on the same scale. Never do that. Always have them scaled. So I should have maybe written bars here as I've done previously. So that was the problem setting, and in the next video lecture we do the sensitivity analysis. That is, we solve the problem. See you there. Bye.